simulation of the retardation effect after applying a simple overload on alloys of aluminum 2024 T351 using the Willenbourg model. In this paper we study the influence of the loading parameters such as the load ratio and the overload rate on both crack propagation. Propagation speed, number of delay cycle, is investigated by using the AFGROW code and the Willenbourg model. After the application of the overload, the slope of the crack propagation curve decreased during a number of delay cycles. This change of slope is affected by the creation of a plastic zone. It is noted that for different load ratios, after application of the overload the cracking rate is affected by the application of the overload, and the cracking speed after applying the overload goes mainly through 4 steps. We can deduce, too, it can also be concluded that an increase in the overload ratio systematically increases the tooth-peak cracking rate either and, which also increases the number of delay cycle. 3. We notice a decrease in the slope of the crack propagation curve. This regression is due to the formation of the plastic zone in the vicinity of the crack. The application of a simple overload affects several parameters. The overload rate has a major impact on the number of delay cycles. Increasing the overload rate increases the number of delay cycles. The overload rate is also the parameter responsible for the size of the plastic zone.